Okay, so you know that article you sent over
Yeah.
about the many worlds interpretation and like
Yeah.
using the Library of Babel as a metaphor for it?
Oh, yeah, right. Yeah.
That was I don't know, that's one of the most like mind-bending things we've talked about,
It really is.
you know. Is it a powerful key to understanding reality or just like a philosophical rabbit hole?
Yeah.
I'm not sure.
I think it's both.
Maybe.
Yeah.
But for all of you listening in, think of this as like your express lane to get into the many worlds interpretation.
It's a very complicated idea.
Right. It's a very complicated idea. It feels like you need like a PhD just to even like approach it.
Right.
And we're going to try to like distill this down to like the core insights about many worlds.
Right. And like, why is this even worth talking about?
Right. Like, why do we even care?
Yeah. And we'll use the Library of Babel thing as kind of a touchstone to kind of come back to.
Yeah, that'll be like our analogy to try to
Explain things.
make sense of this.
Yeah.
Hopefully you'll walk away feeling like you understand this complex topic.
That's the goal.
Without feeling like you just like had your brain quantum entangled or
Oh,
something.
exactly. Yeah. You don't want to.
You don't want to come away more confused than when we started.
Right.
I think the Library of Babel image, this idea of this infinite library with all possible books
Yeah.
is a really powerful way to start thinking about the scale of possibilities that many worlds suggests, right?
It is. And the article kind of gets to that right away. It says, like, look, there's this intuitive appeal to this everything exists interpretation.
Right.
But then how do you actually use that to explain anything specific about the world?
Right. So it's like almost too powerful of an idea.
Yeah.
Because it's like if every possibility exists, then like does anything actually exist?
Right. Does any one thing have any significance?
Right. If everything is equally real, then like nothing is actually real.
It all becomes kind of meaningless.
Right. So that's one of the big like hurdles I think that the article points to with many worlds interpretation.
Totally. And that kind of overwhelming, chaotic possibility. That's really what the Library of Babel kind of helps us think about.
Yeah, it's a good analogy for that.
Like, how do we make sense of this potentially limitless, disorganized multiverse?
Yeah, like where do you even begin with that?
Exactly.
I think the article does a good job of kind of like laying out some of the specific criticisms of many worlds. And like, I guess let's start with just like the basic idea. Like, how would you summarize like the core idea behind the many worlds interpretation?
Yeah. So basically, it's this idea that every time there's a quantum event, one of those moments in quantum mechanics where things are fundamentally uncertain,
Right.
instead of the universe just picking one outcome, it splits.
Oh, wow.
And each possible outcome gets its own universe.
Okay, so it's like constantly branching.
Constantly branching, yeah.
Okay.
And that's where you get into these ideas of like maverick branches and super maverick branches.
Yeah, what are those?
These are like the increasingly strange and unlikely universes that MWI says must exist.
Right.
Like worlds where the laws of physics are different.
Oh, wow.
Or where totally bizarre things happen.
Okay, so like if we can imagine it.
It probably exists somewhere.
Yeah, it exists somewhere.
In the multiverse.
In some branch of the multiverse.
Right.
Okay.
And the article says this is a problem like for science.
Right.
How can you have a theory that accounts for absolutely everything, including all these crazy possibilities, and still use it to predict anything about our universe?
Yeah, because again, it's like if everything is possible, then like is anything actually predictable?
Right, like it undermines the whole point of a scientific theory in a way,
Right.
Which is to kind of help us understand and anticipate what we're going to see.
Yeah, and a fundamental part of quantum mechanics is probability, right?
Right.
So, like, when we do experiments, we get certain outcomes with certain probabilities.
That's the Born rule, right?
Right, the Born rule. But if many worlds is deterministic, like the article says, like the Schrodinger equation just kind of chugs along and determines everything, like a clock.
Like a clock, yeah.
Where do those probabilities come from?
Right.
Like, how do we get this probabilistic world
Yeah, that's a huge tension.
out of this deterministic theory?
And the article points out that attempts to derive the Born rule within the many worlds framework haven't been entirely convincing.
Right.
Because they often sneak in extra assumptions or postulates that weren't there originally.
Okay, so it's like they're adding extra stuff to make it work.
Yeah, it's like you're trying to force it to fit the data instead of it naturally emerging from the theory itself.
Yeah, so for someone who's like trying to understand this from the ground up,
Yeah.
it makes you wonder, like, is this really the simplest explanation?
Right. Is it really as elegant as it claims to be?
Right.
If you need to add all these extra bells and whistles
If you need to like tweak it and,
Yeah.
massage it to make it work.
to make it fit,
Right.
what does that say about the theory itself?
Yeah. And then the article goes on to talk about how some people find many worlds useful as a teaching tool,
Yeah.
even if they don't necessarily buy into it as like a fundamental description of reality.
Right, and especially in quantum computing.
Yeah.
They give the example of decoherence in quantum circuits.
Yeah, what's that all about?
So decoherence is like when a qubit loses its quantumness
Okay.
because it interacts with its environment,
Right.
and MWI gives us a way to visualize that.
Yeah.
Like imagine each possible state of the qubit has its own universe,
Okay.
and as the qubit interacts with its environment,
Huh.
those universes branch.
Oh, yeah.
So when you look at just one qubit later,
Right.
it seems like it's lost its original coherence.
Oh, so it's like we're only seeing one slice
Yeah.
of this much bigger
Yeah.
multiverse picture.
Right.
Okay.
So MWI helps explain why qubits seem to decohere.
So even if like the whole multiverse thing seems a little out there, it can still be helpful to think about these interactions in terms of like branching universes.
Right, it gives you a mental picture.
Yeah.
That can be useful.
Okay, so it's like a good like pedagogical tool.
Exactly. Yeah, even if it's not the ultimate truth,
Right.
it can still be helpful for understanding certain concepts.
Now the article brings up this other analogy, the stone soup analogy.
Oh, yeah, that's a good one.
Can you explain what that is and how it relates to many worlds?
So the stone soup story, it's like this folk tale where these travelers come to a town and they have nothing but a pot and a stone.
Okay.
And they convince the townspeople to each contribute a little bit of food to the pot
Right.
by saying they're making stone soup.
Right.
But in the end, it's actually a delicious soup because everyone's contributed.
Right.
And the article uses this to critique the idea that many worlds is simple,
Okay.
because it starts with just the Schrödinger equation and unitary evolution.
Like that's the stone in the pot.
Exactly.
Okay.
But then to actually make the theory work, to explain what we see, you need to add a lot of extra ingredients.
Okay, so it's like all the postulates and assumptions
Exactly.
just kind of get tacked on.
Yeah, it's like you need to add the vegetables and the spices and everything else.
Right, to actually make it a meal.
To make it a real theory, yeah.
Yeah. So the stone soup analogy is basically saying that many worlds might not be as simple as it seems at first glance.
Totally. Yeah, it might be hiding a lot of complexity under the hood.
And then there's this whole question of like the role of observers in experience.
Yeah, that's a big one.
Which the article also touches on.
And it's a philosophical question, really.
Right.
Like, how do we account for the fact that we experience a single definite reality?
Right, like we don't experience ourselves splitting into multiple copies
Exactly.
every time there's a quantum event.
And the article points out that even with all those extra assumptions we talked about, MWI still struggles to explain our lived experience.
Right, like how do we connect this idea of a constantly branching multiverse with our own subjective sense of being a single observer?
Right, it's a big mystery.
It's a huge mystery.
Yeah.
And then, in the middle of all this, the article brings up this idea of interpretational agnosticism.
Yes.
What is that?
So this is the idea that maybe no single interpretation of quantum mechanics is the be-all and end-all.
Okay.
Maybe we need to be more flexible
Sure.
and use different interpretations for different purposes.
Oh, I see.
Like the article uses the analogy of borrowing different cars.
Oh, yeah?
Like you wouldn't use a sports car to haul lumber.
Right.
So maybe you wouldn't use many worlds to study quantum gravity.
Okay, so each interpretation is like a tool,
Exactly.
and you pick the right tool for the job.
Yeah. Yeah.
And that's a really interesting way to think about it.
Yeah, it's more pragmatic.
Yeah.
It's less about finding the one true interpretation
Right.
and more about using the tools we have to make progress.
So as we wrap up here, what are like the key takeaways you think our listeners should remember?
Well, I think the article highlights some really important philosophical dilemmas in physics,
Yeah.
like the tension between simplicity and complexity,
Yeah.
and the role of metaphysics in science.
What do you mean by metaphysics?
I mean, like those really big questions about the nature of reality.
Okay.
Questions that might not be answerable through experiment alone.
Okay.
And I think it also shows us the value of being open to multiple perspectives.
Right.
Maybe there's not just one right answer.
Yeah.
Maybe we need to use all the tools at our disposal.
And from a more practical standpoint, like what are the key teaching points about many worlds?
Well, one is that it's a really powerful tool for understanding quantum phenomena, even if you don't believe in the multiverse.
Right.
And two is that the Born rule is still a big mystery. Like,
Yeah.
where do probabilities come from in a deterministic theory?
Right.
We don't really know.
Still an open question.
Yeah.
Well, this has been fascinating.
It-
Listener, I hope you found this deep dive helpful.
Yeah.
We've explored a lot of really mind-bending ideas.
We have.
From infinite possibilities to the role of observers.
And that stone soup analogy is really something to think about.
Yeah, it is.
It makes you wonder about simplicity and complexity in science.
It does.
Like, are the simplest explanations always the best?
Right. Or are we just drawn to them because they're easier to grasp?
Exactly.
So here's a final thought for you to consider.
Huh.
Given all the challenges and all the potential of many worlds,
Yeah,
what does it tell us about our own quest to understand reality?
that's a good question.
Is it about finding the most elegant theory? Or is it about finding the theory that best explains what we see?
Maybe both.
Maybe both, yeah.
It's a balance.
Yeah.
And maybe the answer is different for different people.
That's a good point.
Yeah.
Well, thank you for joining us on this deep dive into the many worlds interpretation.
It was fun.
And until next time, keep those questions coming.
Yeah, keep thinking about the big questions.
And we'll see you in the next episode.
See you then.
Bye.
Bye.